Okay, so we should start now. It's already 4:10. We already waited 10 minutes for those who want to attend. We cannot wait more than that. So today we are going to discuss topic number 3, which is general equilibrium and economic efficiency. So far, in previous 3 lecture classes, we have been discussing about the partial equilibrium analysis. And when we determine the equilibrium prices and quantities in the market using this partial equilibrium analysis, we assume that activity in only one market. So means that whatever the analysis we done, we don't consider the impact on other markets, or if there is an impact, we assume it is very minimal and is not significant. But today, we are going to talk about something which is more advanced, you can see, or we consider what is the impact of that particular, what we say, actions that taken in one market or analysis to another market. And this is, we are going to discuss today specifically about these two, which is general equilibrium analysis, efficiency in exchange. Then later, next class, we talk about equity and efficiency. Then we talk about welfare economics. So, as I say, up to this point, we have been focused more on the partial economic analysis, where the activity in one market has little or no effect on other markets. But basically in real life, especially when we're talking about goods and services or output or import, we have substitute, we have a complement. We have also markets are related or interrelated among each other. So this market interrelationship can be very important for managers and for also policy makers to design appropriate policies. And later we are going to see how this will help policy makers. So as I say, this interaction, because we have these complements and substitutes effect. If let's say I'm talking about the price of petrol or the supply and demand of petrol, you may think that this is an energy market. We will have also about transportation market. If the petrol increase, so people, they may not drive to Kuala Lumpur or to Penang, rather than they use transportation or public transports. So you can see it is the energy prices increase lead to shift in the demand of another market. So in the same for the firm, when we're talking about the import, increase in a firm import demand can also cause the market price of the input and the product to rise, and vice versa. So here we can see, to study how the market interrelate, we can use general equilibrium analysis. Unlike this partial equilibrium analysis, general equilibrium analysis determine the prices and quantities in all markets simultaneously. So it is simultaneous determination of these price and quantities in all relevant market, and taking into account the feedback effect. What does mean feedback? Yeah, feedback effect. Feedback effect means that the effect or the price or the quantity adjustment in one market caused by the price and quantity adjustment in related market. As I say, when you have the price of petrol increase, that lead to feedback effect on the public transportation, where the demand for public transportation is increased. And also we will have a spillover effect where it is a change in one market equilibrium as a result of the change in another market equilibrium. So we can see of the petrol prices, for example, when the petrol prices increases due to the supply, for example, the pandemic, or the supply, for example, reduce, or vice versa, the petrol decrease because of the demand of how we say of the petrol decreased in the global world. Demand for the petrol decrease, of the prices automatically will decrease. So this is will encourage, let's say we don't have a lockdown, this is will encourage more people to use private transportation rather than public. So it will affect the demand for public transportation. So in the petroleum market, we will have a new equilibrium. Of course, when the demand shift below, then we will have a new price star and new quantity star. So when people also will demand less public transportation because they can drive their cars, because since the petrol prices are very cheap, therefore also we can see the demand for public transportation decrease, and therefore we will have a new equilibrium. So here we are talking about the spillover effect. So these two things that you really need to remember, because they are very, very important to understand the concept. So we have a feedback effect, which is the feedback effect is the price or quantity adjustment in one market caused by the price or quantity adjustment in another market. And spillover effect is a changes in one market equilibrium as a result of a change of another market equilibrium. For example, also we have here an impact of the change in beef market on each of the chicken, pork, and fish market. If the price of beef increase, people will consume less beef and substitute to either chicken, pork, or fish, and vice versa. If the price of beef decrease, then people will substitute those chicken, pork, and fish. They will consume less and consume more beef. So here we will have both the feedback effect and we have the spillover effect. I hope that you got that is very clear. Then we have these two interdependent markets moving to general equilibrium. So here we assume that a scenario where we have a competitive market of DVDs rental. Either you go and rent DVDs. That business was very famous in the last decades, 10 years ago, or maybe 5 years. And between the movies, theater ticket. So you as a person, you either you go and rent a DVD to watch a movie, or you go to theater or cinema and watch a movie by buying a ticket. So these two goods, we call them substitute, because you as a consumer, you can substitute between either you rent or purchase a DVD, or you buy a ticket and go to cinema and watch it. So since they are substitute, means that changing the price in one market, which is DVD market or rental, or in the cinema market, will lead to change of the price and quantity of the other market. So they are interrelated. So we assume that now here, this is an explanation of this graph. So we assume this is the equilibrium market for this side here is for the number of ticket movies. That's mean for the cinema, right? So at the equilibrium, we have that the quantity at equilibrium is QM, and the price of the ticket is $6. And you see, it is we say that it is a competitive market. So supply interact with the demand, we get that. Then assume that government has imposed $1 tax on each movie ticket And this is what will cause the supply curve to shift from SM to S star M, because those cinema or theater will supply less since the government imposes tax. So the supply curve of those theater or cinema will shift to the left. Therefore, we have new equilibrium here is Q slash or Q comma M, where we have the price at 6.35. So this is what before what we done here and we stop. So we say that one government imposed $1 tax lead to the price of ticket or movie ticket to increase from 6 to 6.35, and the quantity decreased from QM to Q slash or Q comma M. But now we are not talking anymore about this. So because this is a partial equilibrium analysis, but we can go further with the general equilibrium analysis by doing two things. First, we are going to look at the effect of the movie tax that government imposed on the market DVD here. Okay, the market DVD here, or the number of DVDs rented. And second, we will see whether there are any feedback effect from the DVD market to the movie market from here to here. So this affects this, then the feedback come back from here to there. So as we say that, the movie tax affect the demand, the market DVDs, because movies and DVDs are substitute. Since the price of the number of movies ticket increase, so people try to substitute that with number or renting DVDs rather than going to the cinema. So what happened here, we assume at the DVDs market, at the video number of video market, this means DVD, the equilibrium at QV and the price is $3. So you go and rent DVD from shop to watch the movie, the same movie that play in theater, and you pay $3. So since the tax here increase the price of the watching a movie in a cinema or the ticket or theater ticket, then here people will substitute that by using more or renting more DVDs rather than buying a theater ticket. Therefore, the demand for videos or DVDs will increase from DV to DV slash or DV comma here, from here to here. So what happened here now? The quantity of DVDs rented will increase from DV to DV slash V and Q slash V, and the price will increase from 3 to 3.5. So we can say that tax on one product can affect the prices and sales of the other product, which is something that really policymakers should remember and consider when they design the policies. This is what I told you just now. So now we continue the analysis. So what happened after that? Since now the price of DVDs or videos increased from 3 to 3.5, right? The demand for movies will shift here again upward from DM to D/M, since the price of renting a DVD become more expensive. People again will shift from renting DVDs to buying cinema ticket. Therefore, the demand of movie ticket or number of movie ticket or the demand for theater ticket will increase from dm to dm slash or dm comma here, and this will give us a new equilibrium where dm slash with s star m are interacted, and where we have a new equilibrium at q double comma m here. But again, the price will increase to 6.75 instead of 6.35. Thus, here we can say that the partial equilibrium analysis would have underestimated the effect of this tax on the price of movies. So the DVD market is so closely here related to the market of movies that to determine the tax full effect. So now we need a general equilibrium analysis to understand that concept or what happened. So, as I say, here now, you can maybe think that the analysis already stopped, but actually is not yet. As I say, the change in the market price of movies, this is, generated a feedback effect on DVDs. From here, generated the feedback of DVDs that in turn, again, affect the price of movies. So put it in that way. Tax increases the price of movies. This is let people to substitute it to renting DVDs. The demand of DVDs increase. Again, the price of DVDs increase. This is make people to shift again to watching movies in cinema. Therefore, the demand of movie theater or ticket increases the price of the ticket theater. So you can see here, we can determine the equilibrium prices and quantity of both movies and DVDs simultaneously. So here the equilibrium move the price of now again. So again here, when people shifted to the theater, again the demand will keep going and go again to D star M, and we have another equilibrium at D star M and at the price of 6.82. The same thing here. This will lead people to go back to the DVDs rental. So the demand of DVDs also increase and go to D star V, where the price at 3.58. So this keep feedback effect keep going and going and going until reach an equilibrium. That equilibrium in that case is here. In the theater one is Q star M at price 6.82, and for the DVD at Q star V at price 3.58. Could be maybe more than that, another round. This is maybe increase again, maybe it's not that equilibrium. Maybe to another D star 1M and give another higher price. Then people shift from here to here again, and this is increase from D star V to D star V1 and give another one and become here. So once people stop moving from, let's say, here, number of movie ticket to DVD rental, then we stop there. There what we call that is the equilibrium. In this case here, the equilibrium for the movie ticket is priced at 6.82 and the quantity demanded at Q star M, and for the number of videos at price 3.58 and the number of videos or the quantity number of videos at Q star V. So we can say both set of curves are consistent with the price in related markets, and we have no reason to expect that the supply and demand curve in either market will shift further in that scenario. So we assume that is the equilibrium. So this is as a summary. We can have two observations. Without considering the feedback effect with general equilibrium, the impact of tax would have been underestimated. So you can see, if you do not do a general equilibrium analysis, you may think that that tax will increase only the number of movie ticket price from 6 to 6.35. But actually that is underestimation. Actually increasing the number of movie ticket price or the movie ticket price from 6 to 6.82, and also increase the price of DVD rental from 3 to 3.58. But if we don't do the general equilibrium analysis, we do not think that $1 tax in the theater or the ticket in theater would really increase the price of DVD rental. So this is an important consideration for policymakers, as I say, to see how it's very dangerous when you, for example, impose tax and you don't consider other market impact. So also you can check for yourself that in the market for a complement, the tax would be overestimated also. So if I ask you, why is a complement good for movie ticket? When we go to cinema, what we usually buy from the cinema? Can anyone tell me, please? Okay, good. You can buy cola, you can buy popcorn, right? So if government, let's go back here. I go to the first tab. Okay. So we assume that is not number of videos, but cola or popcorn. So when government increase $1 tax, we say the supply decrease and we have new equilibrium. So what happened here? Let's say popcorn is $3. So when less people go to theater, the demand will shift down, right? Will decrease because less people will buy popcorn, and therefore here the price will be somewhere here. Okay, now having the price of popcorn decrease, people may go and watch movies in cinema because they want to enjoy cheaper popcorn. So the demand again for, because here the what we say, the demand, the price of popcorn decrease, right? So this is could encourage people to also go more. So the demand will increase maybe here, then leading to the price increase more. If the price increase more, then go back this effect, then the demand will get less, then the price of popcorn decrease more, and so on. Keep doing in that way. So in both way that you can see that you have this feedback effect and spillover effect. So now we're talking about reaching general equilibrium. To find the general equilibrium, which is prices and quantities in practice, so we say simultaneously find two prices that equate quantity demanded and quantity supplied in all related markets. So for example, for two markets, we need to find a solution of four equations. We have supply of movie ticket, we have the demand of movie ticket, we have the supply of DVD, and we have the demand of DVD. So you should know that even if we were only interested in the market of movies, but actually it would be important to account for the DVD market when determining the impact of a movie tax. Because why? As we say, if we do not also consider the DVD market, the impact of this $1 tax will be underestimated. It will give you less impact, but actually we have more impact. So you see in this example, for example, in the partial equilibrium analysis will lead us to conclude that tax increase the price of movie from only $6 to 6.35. But when we did the general equilibrium analysis, it shows us actually $1 tax imposing of $1 tax actually increase the price of movies or theater movie to 6.82, but not 6.35, and also increase the price of renting DVD to 3.53. So this is very, very important to consider. So we talk about now a feedback between competitive markets. And here we are going to take this example from we call it Holt 1992, where he explained the relationship between two markets, which is corn and soybean. Corn and soybean are. So here we have actually, this is, follow with me, because maybe the graph is not clear. So here D0 with S0 here at E0 equilibrium at 0. This is the supply and this is the demand. This is the equilibrium. So the equilibrium is at price of corn at 2.15 and the quantity at 8.44. So what happened is actually this equilibrium shift from here. A foreign demand for the corn decreases. That caused the export of corn to fall by, let's say, 20%. So the demand decreased from D0 to D1. And we will have a new equilibrium. D1 interact with S0 here. And we can see now the price of corn reduced from 2.15 to only 1.9171, and the quantity, the mandate decreased from 8.44 to only 8.227. So the demand for corn, as I say, since shifted this D0 to D1, so the shock to the corn market affect the soybean market. Consumers substitute toward corn because corn become very cheap compared to soybean. So the initial equilibrium is here. S0 with D0, where we have the price of soybean 4.12 and the quantity demanded is, or equilibrium quantity is 2.07. Since people shifted from consuming soybean to consume corn because the price of corn decreased, then here what happened is the demand curve for soybean shift to the left from D0 to D2 here. This is. And also this is, we'll have also a supply of soybean. Because farmers produce more soybean, okay? Since the demand of corn in international market decreased, farmers also shifted from producing corn to producing soybean. Therefore, the supply increases from S0 to S2 this. And we will have an equilibrium at here E2, where we have the price of soybean decrease from 4.12 to 3.83 to 5, and the quantity change from 207 to only 2.05. So the fall in the price of soybean also relative to the price of corn shift the supply curve of corn to the right. Okay. So now farmers, since the price of soybean decreased, then farmers try to supply more corn, and this is shifted the supply of corn from S0 to S1 to the right. Then we will have a new equilibrium, S1 with D1 here. Then again, the price of corn decreased again from 1.91 to 1.90, and the quantity demand, the quantity equilibrium increased from 8.227 to 8.26. So what happened now? This new fall in the relative price of corn, again, price of corn, caused the soybean demand curve to D4 and shift further to the left here, and supply curve to the S4, which is the red one. So more supply and also less demand, and we will have new equilibrium at 3.8180 and the quantity at 2.050. I think this is will be maybe will be the last, change on equilibrium. I don't think so more than that, but could happen more than that and keep decreasing. So you can see how an effect or reducing in the export of the corn affected both soybean and corn market. And we can see this step by step in here. Okay, this is means that we keep continuing. As I say, we don't know where we stop, but maybe the final here is 1.90505 for the corn, and for the soybean at 3.81742. So you can see, yeah, still have many steps to continue. But here we stop at 3.81. We stop at here. So it could be more than that. So we should, before that, competitive market are efficient because consumer and producer surplus are maximized. That's what we have showed before. In a competitive market, we have no day were lost. So both the consumer and the suppliers maximize the surplus. Also, we can study this in a more detail by examining an exchange, what we call economy, market in which two or more consumers trade two goods among themselves, or same for two countries. So we assume that two persons or two countries, but for simplicity, we assume them they are two persons. So this efficiency in exchange actually is an efficient allocation of good is one where no one can be made better off without making someone else worse off. Means that when we reach a level of this efficiency in exchange, so if I, for example, between me and you, so we are in efficiency, or we call it Pareto efficiency. If I want to make myself better off, but this only on the expense that I have to make you worse off, then what we call it Pareto efficiency. So an efficient allocation of good is one where no one can be made better off without making someone else worse off. So we cannot both of us be better off. If someone wants to be better off, another one, he must be worse off. And this was invented or developed by Vilfredo Pareto, is an Italian economist. So voluntary trade between two parties is mutually beneficial and increases economic efficiency. So when we come to bargaining and we come to an agreement, a mutual agreement between two parties, that will actually increases the economic efficiency of that particular market. So the term of this Pareto efficiency is named after, as I said, this Italian economist who developed the concept of efficiency in exchange. But this Pareto efficiency is not the same as economic efficiency. Why? Because with Pareto efficiency, we know that there is no way to improve the well-being of both individuals or both countries, but we cannot be assured that this arrangement will maximize the joint welfare for both individuals of countries. Means that you may reach to the Pareto efficiency, but you may not maximize the welfare or the surplus of both of them. So this is what we have to understand of this Pareto efficiency. So what is the advantage of the trade? When we do this Pareto efficiency, we have these assumptions. We have two consumers, or could be countries or could be individuals. We have two goods. We are saying two goods because we want to make things not complicated, simple to understand. So both countries or both individuals know each other's preferences. So let's say Malaysia knows Indonesia preference and Indonesia knows Malaysia preferences if they want to trade. Exchanging goods involves zero transaction cost. We assume there is no transaction cost to make also the analysis simple and not complicated, but actually there is transaction cost. And here in this case we name them two individuals but not two countries, James and Karen, where they have a total of 10 units of food and 6 units of clothing. So now they are going to trade on these 10 units of foods and 6 units of clothing. So this is the table. This is the initial allocation. In the initial allocation, James, he has 7 units of food and 1 unit of clothing, and Karen has 3 units of food and 5 units of clothing. Now, to decide whether the trade would be advantage or beneficial for the both parties, we should know their preferences for both the food and the clothes. So we suppose that Karen has a lot clothing, a little food. It has 5 clothing and only 3 food. Suppose that because of Karen has a lot of clothing but only little food, Karen marginal rate of substitution, or the MRS, means that how much he is willing to give up unit of clothes to get 1 unit of food. That's what we call the marginal rate of substitution, to substitute between food and clothes. So we assume that since she has a lot of clothes, her marginal rate of substitution of food for clothing is 3, means that she is willing to get 1 unit of food and she give up 3 units of clothes. Because she doesn't have too much food, she needs food. She say, okay, never mind, I give you 3 units of clothes, give me 1 unit of food. However, James, the marginal rate of substitution of food for clothing, let's we assume it is only half, means that he will give up only half unit of clothing to get 1 unit of food, because he does not have too much clothes, he has only 1. So that he cannot give it all. He say, okay, I give half clothing, I will get 1 food, because actually he has a lot of food. So here the question is, there is room for mutually advantageous trade or beneficial trade because James values clothing more highly than Karen does. Okay? James values clothing. He's willing to give only half of clothes to get 1 food. But Karen, he's willing to give up 3 clothes to get 1 food. So James values clothing more highly than Karen values clothing. Whereas Karen values food more highly than James does, because Karen has less food, so she values the food higher. James has more food, so he values the food less. So to get another unit of food, Karen would be willing to trade up to 3 units, as I say, of clothing. But James will give up only 1 unit of food for only half unit of clothing. So the actual term of this trade now, because they don't have the same MRS, will be depend on the bargaining process that we learned in previous class. Which one they will start bargaining, which one has more influence or more power. Among the possible outcomes are trade 1 unit of food by James for anywhere between half and 3 units of clothing from Karen. So it means that James will give 1 unit of food, then he's going to get between half of clothes that he initiated and 3 of clothes that Karen also initiated. Now they start bargaining. Let's assume, suppose Karen knows that James is willing to give only 1 food for half of clothes. So here, Karen, now we assume that Karen offers James 1 unit of clothing for 1 unit of food, which is more than what James actually, wanted. And James agrees on that because actually it's more. He wants 1 unit of food with only half of clothes. But Karen say, okay, I give you 1 unit of food with 1 unit of clothes, which is much, much better for James. So both will be better off. Why? If he trade 1 unit of food with 1 unit of clothes. So here for James, he will reduce 1 unit of food, become minus 1F. And he substituted with 1 unit of clothes, become 1 plus C. And for Karen, he will gain 1F because he has less food, and he will lose 1 clothes. So the final allocation will be for James, 7 minus 1 of food becomes 6 food, and 1 cotton plus 1 cotton become 2 cotton. And for Karen, 3 food plus 1 food become 4 food, and 5 clothes minus 1 clothes become 4 clothes. So this is the final allocation. When you see here, both of them actually gains because James will have more clothing, which he values more than food, and Karen will have more food, which she values more than clothing. But whether James and Karen's marginal rate of substitutions are different, there is still a room for a mutual beneficial trade because the allocation of resources is not efficient. Since the marginal rate of substitution are still different, are not same, then always they still can find a better way to trade. So conversely, to achieve economic efficiency, the two consumers or the two marginal rate of substitution for both James and Karen must be equal. So MRRs for Karen must be equal to MRR for James. And this is, we can see it later. So this is all explained now here. This is important result also hold when there are many goods and consumer. So means we say that an allocation of goods is efficient only if goods are substituted so that the marginal rate of substitution between any pair of goods is the same for all consumers. Means that MRS for consumer 1 equal to MRS for consumer 2, and equal, if there is another one, MRS for consumer 3. Now, how to decide this economic efficiency, we are going to see it in the next slide. So guys, so we are back. So now, as we say that, in the case of these James and Curry, they can trade and make both of them better off. But the question is that, which of those trades or will allocate good efficiently among these, two consumer or two Karen, let's say, and James, and how much better off will Karen and James could be rather than, for example, the one that we just now we had. So if you want to know at what level they reach the economic efficiency, then we apply this, what we call the Edgeworth box diagram. So why is that? The diagram showing all possible allocations of either two goods or input between two people or countries, or between two production process, and we call this box as Edgeworth box. So we have, in the case of James and Karen, if you remember, we have food and In that box, the food is measured across the horizontal axis. And clothing is measured on the vertical axis. So the length of the goods, we say, the length of the food, we say 10 units between them, right? So for here, in this case, we have length of box in the total amount of food is 10 units. And for the clothes, we say we have 6 units only. So we will have the height of the box is the total amount of 6 units. So here explanation, okay, I have show you here. This is the box. This OJ will show here 0J James clothing from here to up until reach on the top 6. And here OJ will show James food until to 10 food, 10F. Now we go to Karen, okay, opposite. We will have this side on the left, Karen's food until 10, means here 0, 1, 2, 3, 4, 5, 6, 7, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, until 10 food. For James, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, close for James will be this side, 0, 1, 2, 3, 4, 5, 6. And for Karen, opposite side will be 0, 1, 2, 3, 4, 5, 6. So you can see Karen going left to bottom, James going right to up. Okay. So this figure shows on Edgeworth box in which the horizontal axis, as we say, describe the number of units of food, and the vertical is for the units. Now, if you still remember, we see that James has 7 units of food. Okay, in the previous one, initial, the previous table that we see. And this will be read from 0, 1, 2, 3, 4, 5, 6, 7, right? So how much left for Karen? 3. So we read from 0, 1, 2, 3. So Karen has 3 food, James has 7 food. And also, in the vertical axis, we say that James has 1 clothing only, 0, 1. But Karen has 5. So 0, 1, 2, 3, 4, and 5. So we read the opposite. Here 1, here 5 become 6. Here 7, here 3 become 10. So this point A here is the equilibrium. That is very clear. So the initial allocation before trade is at point A, where James has 7 food and 1 cloth, and Karen has 3 food and 5 clothes. Now, what they did, this is the graph now, they traded. So we can also see the effect of trade between Karen and James. So we say James give up 1 food in exchange. So how much become? When James give up 1 food, instead to have 7, he will have 6. That's mean here. Correct? Minus 1 food, 6. And he get 1 cloth. So he has 1, become 2. Here. Same for Karen. Karen lose 1 cloth. From 5 become, for Karen 4, goes the opposite way. And gain 1 food. The one that traded from James. So before she has 3 now, become she has 4. then we will have the new equilibrium at James 6 food to close, and Karen 4 food and 4 close. So at point B, thus represent the market basket for both James and Karen after mutually beneficial trade. So this is how it's work. So if they want to, let's say, they want to allocate or trade in two, means James will give 2 foods, that means 7, become 5 here. Then Karen also will become 5. And the close here, instead to have 2 become 3, and Karen become 3. And this time we will reach also another equilibrium. So each one has 5 food and 3 close, if they want to trade another round, for example. So we say a trade from A to B thus made both Karen and James better off. But the question is that allocation at B is an efficient allocation. Means that we maximize the welfare of both Karen and James. So here the answer will be depend on whether James and Karen marginal rate of substitution, as I say, are the same at B or no. If at point B, the MRS of James equal to the MRS of Karen, then we say we reach to the efficient. But if they are not equal, then we cannot reach an efficient. So I go here now to this graph. So as I say, this depends on James indifference curve are drawn as we usually see them. So this is just an explanation. I will go straight to here. Those previous slides, just an explanation. So if I keep explaining from the slide, you may not understand me. So I will show the graph directly. Later you can read those slides. So here we can see in this figure, several indifferences here curve can be drawn, right? We start with these two. This UJ does mean James. Okay. Actually, for Karen also indifference curve in that way, but we put in opposite way. We rotate it 180 because it works in opposite way. So similar indifference curve for both James and Karen here can be drawn. So here, because his allocation are measured from the original OJ for James, OJ. So these James indifference curve are drawn in the usual way, this one. But for Karen, we have rotated the indifference curve in 180 in that way. Actually, it's also supposed to be in this way, but rotated in that way so that the origin is at the upper right hand corner of the box. So this Karen or Karen's indifference curve is also a convex, just like James. We simply put them in a different perspective. So now that we are already agreed that the red one, UJ1, is for James, indifference curve for James, and UK1 is for Karen. The indifference curve means that for James, he doesn't have any, he can have combination between close and food in any point along this indifference curve to maximize or his welfare. Okay, and same for Karen. So let's examine this curve. We label them as UJ1 for James and UK1 for Crane. So if you can see here at point A, where we have 7 units of food for James and 1 unit of clothes, and 3 units of food for Karen and 5 units of clothes for Karen. So at point A, this both James and Karen's marginal revenue of substitute give the slope of the indifference curve at point A. Here, this is the slope, right? But James' marginal revenue substitution of clothing for food is equal to only 0.5. He trade only 1 food for half cloth. While Karen is 3, he trade 3 food for 1 cloth. So this area here, shaded area here, between the two indifference curve, represent all possible allocation of food and clothing that would make both James and Karen better off than point A. So could be here, could be here, could be here, could be here. But if you go out of this, it will not make them both better off. So now we want to know actually where exactly the point, rather than this A, where both Karen and James should be both of them better off until we reach to the efficiency. So I go to the next. This is the gain from trader. I go to the next slide. And let's say we draw another indifference curve at UJ2. So remember, starting at point A, any trade that moves the allocation of goods outside the shaded area, we say, would make the two, James and Karen, worse off. So we should not go beyond this. So that I move it for James this side, for Karen also should be moved inside. It cannot be outside. If go outside, it makes worse. So the move from A to B, let's say this B, okay? James moved from this UK2 to, UJ1 to UJ2. Karen moved from UK1 to UK2. We come at point B. If you can see here, we still have here this shaded area. Actually, when the two indifference curves are interacted, so means that we are not maximizing or we are not in efficiency. We still can improve it. So the point B is not an efficient point because indifference curve of James UJ2 and indifference curve of Karen UK2, they are intersect. So in this case, James and Karen MRS are not the same, because if they are the same, it must be the two different indifference curve, it must be tangent. That means they touch each other, but they will not intersect. Since they intersect, that means the marginal rate of substitution is not the same. So means if they are not the same, we still have a room for improvement. Then we say that Karen again change the indifference curve to UK3, but James still in the same indifference curve at UJ2. And we have at point C. You can see at point C, the both indifference curve are tangent. They touch each other in only one point. And therefore here at point C, we say the marginal rate of substitute are equal. And therefore we can say here the allocation is efficient. Now you can tell me also, actually, so Karen can stay at UK1 and James could change to UJ3, then we will have a new allocation at DVs, right? So this is also at point D is also a possible efficient allocation depending here on the bargaining power. If Karin bargaining power is more, he can expand his indifference curve, therefore he will be better off than more, then the efficient level will be at C. But if James has more power in bargaining and expand his indifference curve up and up, and Karen stay in the same one at UK1, then indifference curve will be here. Could be also at here. For example, at point E, here where we have UK2 for Karen, and we have UJ, for example, 4 with or 3 with James. So now, this is actually illustrate an important point. Even if a trade from an efficient allocation actually make both people better off, the new equilibrium is not actually necessarily efficient if it is not in a point C or D. That means if it is not the two indifference curve for James and Karen are not tangent. If they are intersect, so yeah, they can be a better off from A to B, but they are not efficient. So they can be more. So they can move to C or D. Okay. So we can say here now that any move outside the shaded area will make one person worse off or closer to their origin. If let's say now James want to be more selfish and want to go another one here at E, then that one of the two will be worse off. So B is a mutually beneficial trade, higher indifference curve for each person at B, but the trade may be beneficial but not efficient. So when it will be efficient, when the marginal rate of substitute is equal, when the indifference curve are tangent, and the allocation here we can see efficient, and in this case it is either at C or at D. So now we talk about another concept, what we call it the contract curve. We have seen that from initial allocation, many possible efficient allocation can be reached through mutually beneficial trade. But to find all possible efficient allocations of food and clothing between Karen and James, we look for all points of tangency between each of their indifference curve. If we don't see this tangent point, that means we don't reach in efficiency. So we need to find the point or all points where this tangency between Karen indifference curve and James indifference happen. So I have this here graph where also there is a possible of a contract, or this show a contract curve. So the curve drawn through all such efficient allocation. We have point E, it is inefficient because the indifference curve of James with indifference curve of Karen are tangent at E. And this is also at F and at G. But the thing is, here as I say, the contract curve shows that all allocation from which no mutually beneficial trade can be made. So here the allocations are efficient because there is no way to reallocate goods to make someone better off without making someone else worse off. So in this figure, we have three allocations labeled as E, F, and G, which are, we call them Pareto efficient, because if you want to make, let's say, James better off, then we need to make carrying worse off and vice versa. Although each involve a different distribution of goods or foods and clothing, because one person could not be made better off without making someone else worse off. This is what we call, again, the Pareto efficient. So here we have several properties of the contract curve may help us to understand the concept of efficiency in exchange. The first, once a point on the contract curve, let's say at point E, has been chosen. If we choose at point E, here actually we reach to the efficient. Now we want to see if we move from E to F, if we are going both of them better off or no. So at this point A, actually there is no way to move to another point on another curve, let's say from E to F, because if we do so, since it is, as we say that it is Pareto efficient, it will make one person worse off. In this case, it is carrying, because we're moving from E to F, actually it will make James more better off, because at E, let's say he has only, let's say 3 food and let's say 1 clothes. If we move to F, he will have maybe 6 food and 2 clothes. And here, Karen, it has 8 food and 4 clothes. If we move to F, making James better, but actually making Karen worse off, because it will have only less food and less clothes. So that we say Karen is worse off because she has less food and less clothing at F than she has at E. So without making further comparison between James and Karen's preference, we cannot compare allocation of E and F. So here we simply know that both are efficient, and in this case, or in this scenario, the Pareto efficiency is a modest goal, where it says that we should make all mutually beneficial exchanges, but it does not say which exchanges are the best. So the Pareto efficiency can be a powerful concept. However, if a change will improve efficiency, it is everyone's self-interest to support this concept. So also we have here, we can frequently improve efficiency even when one aspect of the proposed change makes someone else worse off. So we need only to include the second change, such as the combined set of changes leave maybe someone better off and no one worse off. Once we want to move from one allocation to another, we make sure that at least make one of the two better off without making another one worse off. So, for example, here we have a quota. An example like US consumers maybe gain, or US consumers, for example, for price of petrol with workers or vice versa. Here we have an example of the quota in the steel import or the iron import into the United States. So although the US consumer would enjoy lower prices and a greater selection of cars, because if we remove the quota, means that government or US government doesn't have any restriction that the steel or the iron to go inside the United States. Therefore, when more import, let's say from China, of steels goes to the United States, the price of steels will be cheaper, and therefore the price of cars will be cheaper. So consumers gain. But what happened to the workers? Actually, some of the workers will lose. Those who were working in the steel industry, instead to produce an American steel, which is comparatively expensive than the China steel, so those factories will close because they prefer to import steel from China. Therefore, the workers, they lose. So although the consumers would then enjoy a lower price and greater selection of cars, some US workers would lose their jobs. But the question is, what if eliminating the quota were combined with federal tax? For example, the United States will impose a tax on the steels. We let the steels to come, but we impose a tax. And at the same time, it will give job reallocation subsidies for those steel workers. Give them subsidies and job allocation. So in this case, US consumers would be better off. They still, after accounting for the cost of job subsidies, and the workers also, they will not be worse off because government already give them some subsidies and the allocation. So in this way, would increase the efficiency. So removing of the quota and subsidies to the workers would make both consumers of steels and workers of steels better off, or at least it will make the consumers of steels better off, and it will not make the workers of steels worse off. So this is what we say is US consumer would be better off, and after a time the US worker are no worse off and may be better off. And this package will increase efficiency. Efficiency therefore can be reached with a combined set of changes, leave someone better off and no one worse off. So as a conclusion, I would say that consumers' equilibrium in a competitive market. So in a competitive market, have many actual or potential buyers and sellers. So if people do not like the terms of an exchange, they can always look for another seller who offers a better terms. So in order to make deals in order to make yourself better off, you always had that possibility to find another seller to make with it a deal. And this is what happened also in international trade. So if the bilateral trade between two countries, one country, let's say Malaysia with Japan, if Malaysia says that it has a better chance if we buy the steels from China rather than Japan because the terms and condition of the trade is better off, then it will change the trade from Japan and goes to China or vice versa. So always you have this possibility of choosing what really best maximize and make you better off.